Fuck off, fucked up. Fucking customers. Fuck off, fucking you dick. Fat fucking ass. Fucking useless. Fucking
shit.
Fucking tin. Fucking spaghetti. Fuck off upstairs.
Shit.
Yeah, shit. Fucking right as shit. Fucking sue me. Fucking shocking. Fucking
Hello everybody. God, I haven't uploaded in forever. Welcome back to a brand new video, and today I'm talking about the results of what would happen if my unwillingness to learn proper cryptography collides with my unwillingness to use the Caesar cipher combined with my inability to use other people's cryptography libraries in my school's computers for my school projects. I'd call this mad Frankenstein mess that I thought up with a friend during break and lunch the advanced Caesar cipher. I'm really not sure if anyone already thought of this before. If you have, let me know in the comments, but here it goes. I was making a school project, and one of the requirements was to have only authorized users be able to use the little console game I was making. Now, most normal people in my class stored all of the user data in one big text file that's completely unencrypted, but I, in my infinite paranoia, thought it would be neat to encrypt the user data using the username and password concatenated as the encryption key and calling the encrypted file username plus password hashed.json. Now this was all well and good, except my school's PCs wouldn't let me install any encryption modules for Python, and so I had to make my own little module to use. I wanted to go with a Caesar cipher, right? But as I mentioned earlier, I don't like the Caesar cipher precisely because it's easily cracked. Yet, I still liked the idea of, shifting letters, and the Caesar cipher is kinda easy to do, and so I ran with it. Oh yeah, if you don't know what Caesar cipher is for some reason, I suggest you check this video out. It's in the description. This cipher requires a quote-unquote shift map, as I call it. It's a list of characters. It must at least contain all the characters in your to-be-encrypted text, if not more. My one's just all the printable characters that Python tells me are printable if I type string.printable into the shell, minus the annoying \r character because it's really hard to deal with. Now, the second thing we need to decide is the chunk size. The message that we want to encrypt will be split into portions, and chunk size is simply the size of each portion of your message. I went with 64 because the hashing algorithm I used, SHA-256, returns 64 characters after hashing. Oh, you'll also need a hashing algorithm too? Just saying. Now to the actual encrypting. The encryption key must be hashed. The resulting characters are going to be used instead of the key. We add this hash of the key to the beginning of the message, which is used later for verification. Then we must also split the message we are trying to encrypt into even chunks using the chunk size decided earlier. If at the end the last chunk isn't exactly to the chunk size, just leave it at that. You don't need to fill it in at all with like zeros or something. Next you will derive the quote-unquote shift chain. I will explain later what that does, but to create it you loop through the number of chunks, and then for each chunk you hash the hash of the key plus the counter so that you have a unique chunk-sized character string for each chunk, and it is derived from the key. Now you take each of these unique characters and you turn them into numbers. You can use whatever method you want, but I just used Python's ORD function. This resulting list of lists of numbers is what I call the shift chain. Now comes the Caesar cipher-ish part. For each chunk of your message, you have a list of numbers, and for each character within the chunk, you have a specific number. So what you need to do is shift each letter by its corresponding number in the shift chain along the shift map. To encrypt, you shift forward. If the shifting goes beyond the shift map size, just start at the other end, just like the Caesar cipher. After all the shifting, just join up the shifted characters and you have your newly encrypted string. To decrypt, it's the same, but when it comes to shifting, you shift backwards and not forwards. Once shifted, you check if the first chunk is the hash of the key. If it is, you have successfully decrypted the message. So you remove the first chunk and display the message. If it's not, the message hasn't been decrypted correctly, and I don't know, you throw an error or whatever else you want to do. That's it. I've made a Python implementation for this cipher. If you want, you can check out my chicken scratch code in the description. But for now, I will demonstrate the functionality of the cipher. Roll it! So we're at the computer, and this is the part where I show you what this thing can do. well, my implementation of it. First thing first, it obviously throws an error if you try to directly run it through the file. And I intentionally did that because I don't want a module to be directly run. I want it to be imported into something else. But you could still obviously run functions. So we're first going to just test out if, well, not test, but demonstrate that encryption and decryption works. So the easiest way to do that is to just write decrypt, and then you do the encrypted message, and then you give the key. And obviously, in order to get the encrypted message, you first have to encrypt it, so you give the original message and the key. So you get encrypted message, you get decrypted message. If it works, we should get message, and we get message. It works. Or you could do this, which is just a breakdown of what I did before. Encrypt, result, decrypt, message. Now we're going to try and build a file encryptor with this. So create a new Python file and then edit it with idle. Import all the contents of the crypt file, just like so. So now we import a bunch of other stuff like keyboard, and this is used to check if the E is pressed, and if it's pressed, then you can exit the entire program. Yeah, just really useful. Then we have name, and then you enter the name of the file you want to be encrypted, and you try to open the file and read its contents. If it's not there, it'll probably throw an error, at which point you just print no such file. And if we try and create a file, we will call it hello.txt, and we will write something in there, such as hello. Now that we've opened and read the file, we need to decide if we're decrypting it or encrypting it. And we do that by giving the user the choice of doing one or the other, and then we check with an if statement which one it is. Now if the choice is to encrypt, we're just going to have to encrypt the file with a key. So what we do is we ask for a key. Then we encrypt the contents of the file with the key and write it to the file, overwriting the original stuff. If we're trying to decrypt it, then we're going to have to pass it through the decrypt function and store it back in the file variable. If the file is not equal to none, which means that it didn't decrypt properly, then we obviously replace the contents of the file, just like so. Anything else, then we just inform the user that their key is wrong. Let's see how this plays out. We type in the file name, then we say we want to encrypt it, then we type in the key, and done. We should have an encrypted hello file. After messing around real quick, I just changed some few things. I changed file to name. So the file name again is hello.txt, and we are encrypting it. The key is key. And we should have an encrypted hello.txt. Excellent. Now we'll try and decrypt it. So we do hello.txt. We're decrypting it. And the key is key. And we should have hello. So yeah, that's the Caesar Cypher. That's how to make an encryption file encryptor out of it. That's the demo. I'm just gonna be keeping on pressing E and then enter. Done. Exited. Cool. Now, this is a much stronger, in my opinion, cipher than the standard Caesar cipher, but it isn't without its flaws that I'm not actually bothered to search for. It's perhaps easily cracked by means I don't know, or it's slow, or it's not very versatile, yet it has its upsides. It's simple, and it works on my school's PC. That's it. Alright guys, this has been the video for today. I hope you liked it, I hope you learned something new. So please smash the like button, subscribe, share this video with your friends. Good day. Oh yeah, don't forget to comment as well. That's very useful.